You should know that derivative is always rate of change. So when there is a function y equals to fx, then dy by dt represents the rate of change of this function with respect to t. Rate of change of function fx with respect to t. So this can be useful for finding a lot of things, and it has extensive application in differentiation. Let's start with some very basic examples. Suppose there is a function a which is area of a circle which is variable. So if we find dA by dt, it represents the rate of change of area of the circle. It has very simple application, and with the help of a few examples, this topic can be easily understood. Let us consider this example, which goes like a circular pool of water is expanding at the rate of 32 pi square centimeter per second. At what rate is the radius expanding when radius is 4 centimeter? So here we are mentioned the rate at which the circular pool of water is expanding. So obviously it is the rate of change of its area with respect to time. So dA by dt is given as 32 pi square centimeter per second. Now we have to find at which the radius is expanding when radius is given as 4 centimeters. So first of all, let's establish a relationship between the area and the radius, which is obviously a equals to pi r square. That area of the circle is equals to pi r square. And if we differentiate both sides with respect to t, we will get dA by dt is equals to 2 pi r dr by dt, which is the application of chain rule. So when radius is 4 centimeter and dr by dt is this value, so then the question can be modified to 32 pi equals to 2 pi into 4 times dr by dt. So with the help of a little algebra, it can be verified that dr by dt is 32 pi over 8 pi, which is 4 centimeter per second. Let us consider another example. It reads like the radius of a circle is increasing at the rate of 0.5 centimeter per second. So whatever we are given is noted down here. So it is dr by dt, the rate of change of radius is 0.5 centimeter per second. Because it is increasing, so it should be positive. Whenever something is decreasing, we should know that it must be negative in sign. We have to find the rate at which the circumference and its area are increasing. We know that the circumference of a circle is 2 pi r. So if we differentiate it with respect to t, we will have dc by dt is equals to 2 pi dr by dt. So at the given value of dr by dt, this thing will become 2 pi times 0.5, or simply pi centimeter per second. Now we have to know the rate at which the area is increasing. Area of a circle is pi r square. If we differentiate it both sides with respect to t, we will get dA by dt is equals to 2 pi r dr by dt. So the rate at which the area is increasing will be 2 pi r times 0.5, which is pi r centimeter square per second. Because we are not given any particular radius, so it will be a variable thing When the radius of the circle is larger, the rate at which the area is increasing is also larger. When the radius is smaller, this rate is going to be smaller. For example, at some values of radius, the dr by dt would have a few values. Sorry, rate of change of area would have a few values. So if the radius is 1 centimeter, then dA by dt will be pi. If the radius is 2, it will be 2 into pi, that is 2 pi. When the radius is 10, then the answer is going to be 10 pi centimeters square per second.